Okay, today we will have a presentation by group, okay, on the project. So at first you have to identify the problem and take a case study, and you have to use the advanced analytical model. So try to get the data sets and provide detailed solution using deep learning techniques in artificial neural network. Okay, and then you have to provide step by step on how data be analyzed with deep learning, right? You can use this guide as a cross-industry standard process for data mining, where you can use for your project. Alright? And today we will have a project presentation with the project leader and the group members. Okay? Okay, thank you.
Hello, Doctor. Our group lead today want to present sign language character.
For the introduction, the sign language is essential for communication among the hearing impaired and in Malaysia, the official language is Bahasa Isyarat Malaysia, BIM. Most existing AI systems focus on static signs like alphabets, but the real conversations use dynamic gestures. Also, there is not public dataset for BIM gestures. To solve this, we built our own dataset with 33 dynamic signs and developed deep learning models to recognize them in real time. A step-by-step installation on Python programming language. Before install Python, we need to check if the Python is already installed to avoid the duplicate installation. For the window, we can open command prompt to try and type the Python version or Python 3 version. For the Mac OS or Linux, we can open the terminal and type Python version or Python 3 version. Then if we see the Python, it shows the Python 3.x.x, then it is already installed. If not, then we can go to the next step, is download and install Python. We can start download Python by visit official Python website and click big yellow button that say download Python 3.x.x. Then we need to choose the correct version for operating system. For the Windows, it runs downloaded.exe file. The Mac OS is .pkg file, and Linux is installed by the terminal. Then we can follow the instruction to install the Python. After that, we can go to the next step, which is verify the installation. We can open the terminal or command prompt and type Python version or Python 3 version. Then if we see something like Python 3.x.x come up, that means that the installation is successful.
So next I will present about the explanation of deep learning using Python. For our project, we are using TensorFlow, which helps to build and train the deep learning model easily. We import different layers like LSTM, GRU, and DANS to handle image and sequence data. These layers are perfect use for sign language videos. Other than that, layers like drop-up and mesh pooling only help improve the model performance and prevent overfitting. We also use tools like categorical to format our output. And we also use callbacks like early stopping to control training automatically. Next, the Adam optimizer helps us to improve the training speed and stability. Basically, all these tools help us to train a smart model that can learn and translate hand signs into text.
For the details on their functions part, the deep learning is an extension of artificial neural network, but it has 3 or more hidden layers between the input and output layers. Then, for the training process in deep learning, there are several steps that enable neural network to learn from data. It begins with forward propagation and followed by the loss calculation. After that is back propagation, and the last is optimizations. Then, to apply this training process effectively, there are some DL architectures have developed, like CNN, RNN, LSTM, GRU, and transformer. For the CNN, it's used to the image related task. Then the RNN is used for sequences data like time series, but it will struggle with long-term dependency. So we can use LSTM or GRU because they better handle longer sequence.
Now I'm going to talk about the detailed description for raw data. Most public sign language dataset only include static sign like A to Z or 0 to 9, which don't reflect real-life BIM usage. So we record our own dataset. We refer to the official BIM website and choose 23 real-life sign capture. And each sign have 150 video, and each video contain 30 frames, like 30 image in sequence. We didn't use the raw video directly because it takes too much memory and processing time. Model don't need background lighting or face, it only need the body and hand movement. So we extract 3D coordinate of left hand, right hand, and the body pose for each frame, and save as the MPY file. This is the example of one frame from the MP4, and then we extract the key point from NumPy array, and this is the key point example value in NumPy array. Next, this is our flowchart of our project sign language translator. Can take a look. And this I'm going to talk about the learning process. We use 4 models, which are LSTM, CNN combined with LSTM, and TCN, and also the RCNN combined with LSTM. The signal flow is feed forward, which is from input layers to hidden layer and then to the output layer. The hidden layer is varied by different model, and the output have 23 units for BIM classes. The weight is initialized randomly and update using back propagation, and it is used during training to compare predicted output and actual labor using categorical cross entropy loss. It also calculates gradient, which means how much each weight contribute to the error, and use Adam optimizer to adjust weight to reduce loss. The learning process is repeated for 50 efforts to improve the accuracy.
After that, I will present step-by-step learning, analysis, and finding. First step is import library, like CV2, NumPy, TensorFlow, MiniFly, and Xcanon. The second is define part and constant. Step 3 for data collection function. Step 4 for video processing and key point extraction. Step 5 for model training. Step 6 for data pre-processing and normalization, and the last is model training and relation. Then I will present data analysis with real models and their output. First, TCN accuracy over import and loss over import. Accuracy over import increase moving toward accuracy 1. For the loss over import, decrease to 0. This graph is for CNN plus LSTM accuracy over import and loss over import. This one for LSTM, and the last for RCNN plus LSTM. Training accuracy and validation accuracy have big gap between them. Can go for training loss and validation loss. This means there are some overfitting occur.
Then I will talk about the result for our project. So for our project, we are using the confusion matrix. This is because confusion matrix can show the counts of true and false prediction for each class of section. And this is the TCN confusion matrix. You can see that the diagonal values for TCN is higher, and there is few misclassification compared to other deep learning methods. For example, the capture like Magan and Mina are slightly familiar, which cause the misclassifications. And then here is the LSTM confusion matrix and the combination of CNN and LSTM confusion matrix. The diagonal values for LSTM is slightly better than CNN plus LSTM. So the accuracy is more higher than the combination CNN and LSTM. Last is the RCNN plus LSTM confusion matrix. The prediction result for the combination methods of RCNN and LSTM has the slowest diagonal values compared to the previous deep learning methods. There are many classifications due to its high complexity. For example, the sign language of Macan is predicted wrongly 7 times as minimal. And this is the overview result for 4 deep learning methods. The TCN has the best performance since the training duration is the shortest and the accuracy is the highest, while the RCNN plus LSTM has the worst performance because of the accuracy is the lowest. As a result, the highest accuracy, lower training duration, and the fastest inference speed of TCN provide the best performance on our project, which can indicate that it is suitable for real-time prediction of sign language capture.
For the conclusion, this project addresses the gap in current AI-based sign language translators by focusing on dynamic gauges in Bahasa Isyarat Malaysia (BIM). We built a custom dataset and tested deep learning models to classify 33 BIM gauges. The TCN achieved the best accuracy and processing speed, making it suitable for real-time application.
So right now I will demonstrate how the sign language recognition work in real time. So this is the output you see from the OpenCV camera, where it will take the input from the camera and display in our PC. And here you can see the key point of each of the key point on our left hand, right hands. And these are the features that we will track and feed to our model to do inferencing to predict what kind of gesture that I'm doing. So for example, we can do a hi. So it works with a right hand and it also works with a left hands. Okay. So actually the idea is to integrate this model in a real-time application, such as maybe you can use it in a meeting platform where people can use this to have conversation with deaf people or mute people, and they can use it to do daily conversations such as like, hi, apa khabar? And then the other person maybe can reply like, yeah, khabar baik. Yeah, this is the one of the limitation where two similar gesture might get overlap, and this can be improved by augmenting the data, increasing the data size in the future. That's all for the demonstration. And thank you for listening.
Hello, everyone. Have any questions?
So I want to ask, what future improvement can you suggest for our project?
For our project, first we can expand the dataset to include more BIM picture. Second, optimize model for edge of model deployment. And the last is integrate the Translator into a user-friendly app with camera input.
Sounds like good. Thank you for your suggestion.